All right, so we're going to be on day 2, making predictions. This is day 2 of lesson 1 and topic 3. The table shown lists the average global temperature in the 5-year span from 1957 all the way to 2016. What is the range? So this question is a little bit different. Range represents your Y values, but it also represents the difference between your biggest number and your smallest number. So here my biggest number would be 58,448 minus my smallest number, which is, I assumed it was at the top, but it may not be, and that's actually 58.448, not 58,000. Minus my smallest number, I believe is actually the second number here, 57.121, which gives me a range of 1.327 degrees Fahrenheit. So we're talking about temperature. Number 2, identify the independent and dependent quantities and their units of measurement. So my independent is the number of year span, and the dependent is my average temperature. Let's see, so the year span, of course, is in years, and then the temperature is in degrees Fahrenheit. Number 3, do the data itself represent a function? Does it appear that there is a specific function that could model this data set? If so, describe the function. If not, state why. So remember, a function is where your x values do not repeat. So I'm looking at my x values and they are not repeating. I look at my y values. Every y value is mapped to a different x value. So for number 3, yes, we have a function. So we need to figure out what type of function it is. If you notice, the data is growing at a constant rate, so we can represent this as a linear function. Number 4, we're going to use technology to graph the scatter plot, demonstrating the relationship between the time spans and temperature. What association do you notice? All right, so we're going to do what we did in the previous lesson, and we're going to calculate the linear regression. So I'm going to hit Stat, and I'm going to edit, and I'm going to edit these numbers in. 1, enter. 2, enter. 3, enter. 4, 5, 6, 7, 8, 9, 10, 11, and 12. And go over to list 2, and you notice I'm just going to type over them. So 57.25. Okay. And we're not going to use list 3, so we're going to go back to Stat, and we're going to calculate the linear regression. And we're going to use list 1 and list 2. We're going to calculate. So here, notice that our correlation coefficient is 0.96. That's a strong correlation. So the line that we have here would be y equals 0.126x plus about 56.9. Now, this slope is a positive slope. That means this line is going to be increasing. So that means we're going to have a positive association. Now let's stop here and let's look at some various scatter plots and talk about association. So here I've drawn 3 graphs. I want to show you an example of positive association. This is increasing. Some people call it correlation or association, but this is positive. It's going up. If you notice some dots that are decreasing, this is a negative association. If you have some dots that don't seem to be going up or down, this is no association, or maybe a constant association. Let's go back and answer 5. Between which consecutive span was there a decrease in average global temperature? So let's see, we're decreasing right here, then we're increasing, and then we're decreasing again, and then we're increasing, decreasing a little bit, increasing, decreasing, increasing, increasing, decreasing, and here we're increasing. So between 0 and 1 and 3 and 4 and 5, so here between this span we're decreasing. Between 3 and 4 we're decreasing. Between 5 and 6 we're decreasing. Between 7 and 8 we're decreasing. And between 10 and 11 those numbers are decreasing. Number 6, use your graphing technology to determine the regression equation for the average global temperature data. Then sketch the data points and the line of best fit that you see. What is the relationship? I'm going to go ahead and do that on my graphing calculator. So if I go to turn my plot on, so I'm going to go to plot and turn it on. And that's going to plot list 1 and list 2 and hit graph. And I need to zoom out just to, and I probably need to zoom out again. So there are my points. I can kind of go zoom in and zoom out again. There they are. So I'm just zooming in and zooming out. That's all I'm doing. And you can see how some of them are going up, some of them are going down. And then if I go under my y equals, and notice my plot is on. Those are just plotting stat points. And I type in my line of linear regression. Let's see, what was that? It was 0.126x plus 56.9 and graph that. So you see that my linear regression line is going through those data points, and that's why they call it the line of best fit. So if you can do it on your calculator, I wouldn't worry too much about plotting it on the graph here. Number 7, what is the relationship between the equation of the line of best fit and the association you noticed with the graph? Do you think the line fits the data well? Yes, I do think that data fits well. We know that it does because our correlation coefficient was a 0.9, and that's a strong correlation. And those graph points were very close together. Number 8, for each expression from your linear regression equation about global temperatures, write an appropriate unit of measure that describes the contextual meaning, then choose a term from the word box to describe the mathematical meaning of each part. All right, so we got input, output, rate of change, and y-intercept. So the unit that we're using for f of x would be our degrees Fahrenheit. And what the contextual meaning is we're going to predict the average temperature. The mathematical meaning, it's your output value. Your 0.1259 is your rise per span of years. Your degree rise per span of years. So it's your average temperature. Your change in your average temperature. So this is your rate of change. Rate of change is another word for slope. Your x is the span of years, the span number. And we can write span number again. What that means is that's your input value. Your 56.863, that's your degrees Fahrenheit. When you start at span of 0, that is your average temperature. And that's called your y-intercept. That's where it crosses the y-axis. Number 9, use your linear regression equation to predict the average global temperature for the years between 2032 and 2036. So this represents the 16th year span. So 16th is going to be your x. So y equals 0.1259 times 16 plus your, what did we say, 56.9 that we used for the equation. So we rounded that to 126 and we used 56.9. So 0.126 times the 16th plus 56.9, we get about 58.9 degrees Fahrenheit. Activity 1.3. Making predictions within an outside inside and outside a data set. The music industry is constantly changing how it delivers music to the listeners. The table shows the percent of total U.S. music sales revenues from streaming. Use the graphing technology to determine the linear regression for the equation. So we're going to practice this again. Go to Stat, Edit, and we're going to type in these numbers. So my X value are going to be my years. My Y value is going to be the prediction. So instead of putting in 2010, 2011, we could actually start with 0 or 1. Let's start with 0. Let's say this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. If it doesn't work, we'll change it. So 0 is going to represent 2010. And I need to delete all the other numbers that I have in there and just have 0 through 5. So I'm going to have 7, 9, 15, 21, 27, 34, and then I'm going to delete my other values. That looks good. Then go back to Stat and calculate. Go down to linear regression. Keep hitting enter until you calculate. So I've got a 0.98. That is a strong correlation. So let's see, my linear regression would be y equals 6x plus 4.3 repeating. So I looked back at my numbers and I actually entered in the wrong value there. I think I put in a 37 and that should be a 34 according to the data. So when I calculate my linear regression, I should get about 5.6 for my slope, and my y-intercept is about 4.9. An even stronger correlation, 0.99. So the closer we are to 1, the stronger the correlation is. So that looks good. Interpret the equation of the lines in terms of this problem. Okay. The percentage of U.S. music sale revenue from streaming rises about 5.6. every year. It's starting at 4.9%. It started at 4.9% and it rose about 5.6% each year. If there is a linear association between the independent and the dependent variables of the data set, can you use a linear regression to make predictions within the data set? Using a linear regression to make predictions within the data set is called interpolation. Use your equation to predict the percentage of streaming revenues in 2013. Compare the predicted value percent in 2013 with the actual value. So if I take this equation, y equals 5.6x plus 4.9. And I need to figure out 2013, which is already stated up here as 21%. That's my third term. So I'm going to put in 3 for x. So I'll just quickly do it in my calculator. I've got 5.6 times 3 plus 4.9. So it gives me about 21.7. And that's it's close to what we have here. 21.7%. Number 4, compute the predicted value percent for 2011 and compare it to the actual value. All right, so 2011 is my first term, so y equals 5.6 times 1 plus 4.9. So 5.6 plus 4.9 gives me a 10.5%. And it gives me about 9 there. So we're a little off. Number 5, do you think a prediction made using interpolation will always be close to the actual value? Yes, as long as the line of best fit has a good, strong correlation. To make predictions for values of x that are outside of the data set are called extrapolation. Use the equation to predict the percent of streaming revenues in 2040. So here we're going to say that x is 30. And I'm going to plug that into the equation of y equals 5.6 times 30 plus 4.9. .6 times 30, plus 4.9 gives me about 172.9%. Plug in 2004, which would be x equals -10, and I should get a -28.7%. Are these predictions reasonable? Explain your reasoning. No, more than 100% of music revenues from streaming isn't possible, and a -% from streaming isn't possible. So we can't make over 100%, and we can't make a negative percentage. Go ahead and explore Tell Me Everything. Also complete the assignment at the end of this lesson. This concludes today's video.